Okay, and our last speaker, David Schlegel, will tell us about Spec-S5 now.
Great. Okay, thank you. So I'm David Schlegel from Lawrence Berkeley National Lab in the province of California. Thank you for having us. Okay, I'm not done yet. Okay. So I do want to make the point, the last 10 years for spectroscopists or galaxy spectroscopists, it's been kind of a time of construction. We've now entered this golden age of redshift surveys, both in space and on the ground. So of these, DESI actually being the first of these to see first light, and actually the largest. So we've been busy publishing in the New York Times. We have also published in PhysRev, so just a couple links here to PhysRev. Will talked about this yesterday, so all I'm going to say here is we're living in interesting times. To date, from this project, we already have 41.1 million galaxy redshifts. We actually also have 16.3 million stellar spectra as of last night. Ting Li and only about 5 other people are looking at all these spectra. But all of these redshift surveys happening this decade, they're mostly in the redshift less than 2 universe. So in fact, if you add up all of them and ask, how many redshifts will we have above redshift of 2, it's only a couple million. And for cosmologists, most of the volume of the universe, most of the information content is actually at higher redshift. So that's really our desire to address the science questions that we have, is to get to the higher redshift universe. Okay, so this is the reference design for the next generation project that we're currently planning. So this is what's called Spec-S5 now. So to my physics colleagues, I'm in a physics lab. They view this as all physics beyond the standard model that we're exploring. But this reference design, what we're looking at mapping, it's hundreds of millions of galaxies, hundreds of millions of stars. And the details of this will evolve as we're approaching the project, but at least this is a reference point that we've now published. Okay, and then as far as a reference design, we're looking at designs that are at least 15x DESI as far as survey speed and power. The idea here is to rebuild 2 existing telescopes, one in each hemisphere, so that we have full sky coverage. And we're looking at existing massive 4-meter telescopes where we've had this epiphany that we can actually convert many of them from a 4-meter to a 6-meter mirror on the existing telescope, existing mounts, and so forth. So our baseline studies are from the 2 Noir Lab telescopes, so the Kitt Peak 4-meter and the CTAO 4-meter, where we preserve the building, the telescopes, but we pull out the mirror and we put in a 6-meter segmented primary mirror, and then lots of robots. So we've had an R&D effort on robots that actually dates back now to 2006. So we've gone through many generations of robots. For this project, we're prototyping a number of different designs that have a packing density of 6 millimeters robot to robot. So this would allow us to build 13,000 fiber robots on each focal plane. So in comparison to DESI, which currently is the biggest such robotic focal plane, it's 3 times the density of robots. The DESI spectrographs, we've looked at this design again. We don't actually want to change anything. The spectrographs are fantastic for what we're doing. And I'll just make the point here that these are French spectrographs. They only speak French. The one modification we're looking at, though, is actually to add another arm that would go into the infrared And this is based on some germanium CCDs that we've been developing. Okay, so this project, it's on the roadmap for U.S. Department of Energy. So this is, we're not in construction yet. We're in an R&D phase, heavily doing R&D on kind of the high risk or long lead items. So that's primarily detector development, the segmented primary mirror, and the fiber robots, and supported right now by DOE and private foundations. Okay, so why am I here other than being in the province of California? So the first reason is CFHT is uniquely suited for finding these galaxies above redshift of 2. So that's what we discussed yesterday. And both the Canadian and French communities have been major partners in these projects to date, and we expect to continue this partnership. And another reason is this is one of those telescopes that we could consider in the future when we go through an alternatives analysis, basically selecting the best sites to deploy the Spec-S5 project on. We'd like to evaluate different sites as well. So CFHT looks like it is a viable platform for this. You know, it's one of these massively overbuilt. God, I wish they still built them like this today, right? You look at some other ones like UCURT, you know, you put 100 kilos on it, it's going to fall over. Here you can do really massive instrumentation. So we'd like to consider this potentially as a potential site for Spec-S5, or, you know, we are doing all this R&D right now, and this would be transferable to CFHT. You know, if CFHT wanted to use any of these technologies for whatever MSE becomes in the future. Okay, that's all I had. Thank you.
Okay, I think in the interest of time, what we should do is start the discussion. And
thanks. Al McConaughey from Victoria HA. Really nice. So to what extent do the two telescopes or the two systems have to be identical? Because if one of them was to be, say, on Mauna Kea, where you have a much better image quality than you would at, say, alternative sites, you might want to change the size of the fibers and do some optimizations there. Is that considered to be a good thing, or is that considered to be a bad thing?
I mean, our base, the baseline design is that they would be identical. Obviously, we could look at changes, be less convenient in some ways. But I will say one of the interesting things is if you look at what's the optimal fiber size for what we're doing here, it's a pretty flat optimum. So it's which you might not expect, but once you fold everything, and so the better seeing, you definitely gain, but you gain in all cases, but it's flatter than you would expect.
Danielle?
So you're going to retrofit your telescope with a bigger mirror. Are you going to run into vignetting problems from the slit, or are you going to make the dome slit bigger? How are you going to deal with that?
So the dome slits on these particular telescopes are actually large enough to accommodate what we need. There's a detail where the telescope control is not good enough because the controllers date back to 1900 or whatever, and they kind of move plus or minus half a meter. We need it better than that. CFHT, it looks like the dome slit's slightly too small.
But that is that's
yeah, except with the wider field that cuts off another quarter meter on either side. Well, in parts of the field. Anyway, this hasn't been studied in detail, but yeah, it's a good question. Lots of details, sure.
So what are the decisive changes or decisive physics you will get with a third site?
Sorry, the physics with the third site?
Yeah, you have already two sites. what will bring the third cycle?
Are you just so you get more volume of the universe? So for our baseline design here, 2 telescopes, 6 years of operations, we do what we initially want to do. But then what are the questions in 2035, 2040? I don't know. But the more, we're not running out of things to do with DESI. Let's put it that way.
This is probably going to the answer to this question is probably going to make me feel stupid for asking it, but I'm confused by something. What's stopping you from repurposing MILE to do the northern source finding experiment leading up to this spectrum? Why do you need CFHT to do that for you?
So the CFHT imaging that we were talking about yesterday is primarily for DESI-2, which in a sense you could view as the pathfinder to Spec-S5. So CFHT could super effectively do kind of, this redshift greater than 2 universe to some volume over some area, but it can't accomplish everything that we're talking about doing with Spec-S5. So the plan for Spec-S5 is actually to refit Rubin Observatory with the filters necessary to select the high redshift galaxies after Rubin finishes its initial 10-year survey. Which is why we need Rubin to start. Like, they really should start. Like, they have a telescope, they have a camera, yeah.
Do you expect to move slightly in the red for the spectroscopy, since you want to go to high redshift? Is there any gain to stay in the same wavelength domain than DESI, or do you need to expand a little bit in the red?
Yeah, so that's a good question. Why do we need to go to the red? For this reference mission, we don't need to go to the red at all. And in fact, we don't even need our reddest channel for this, because for these redshift 2 to 5 galaxies, we really just need blue spectroscopy. On the other hand, by going out to at least a micron, then you get to get the redshifts of the things that you might have messed up if you didn't have that part of the wavelength coverage. And in fact, if you can span up to 1.2 microns, then there's no more redshift desert. So you have sufficient wavelength coverage that you always see strong features no matter what the redshift is. For DESI right now, we have this window between redshift 1.6 and 2.0 where we just fail. So it kind of removes that redshift hole. The other reason, though, is the bigger the wavelength coverage you have, just the more opportunity you have to. Thank you. Obviously, the more opportunity you have to adjust what science you want to attack in the future. And so, if you told me, when we actually start this survey, is it really exactly redshifts 2 to 5 that you're going to be mapping? That might not be the answer. The answer might be we've decided by then, there's early dark energy. We need to go out to redshift of, 3 to 7. Like, let's explore that. But this is one of the nice things about these ground-based instruments where you have the capability to actually change things and target. Is, you have that flexibility to change what you're looking at.
Hey, what's the timeline?
So the timeline we would like is listed here. So we're in R&D right now. As you know, things are very uncertain in the U.S. right now, so I would not want to commit to any timeline, but it's certainly on the roadmap.